Participant session will start at 2:15 p.m. We have 7 more minutes. Participant session will start at 2:15 p.m. We have 6 more minutes. Speaker entered into our session. I am going to allow speaker. Good afternoon, Suresh Babu, sir. Suresh Babu, sir. Good afternoon, sir.
Yeah, good afternoon, sir. Good afternoon.
Good afternoon. We have 8 more minutes, sir.
No problem, no issue.
I'm giving course, you can direct at 2:50, sir. I'm giving you as a co-host, sir. So from 2:15 hours, you can start, sir. But
Sir, your
coordinator
voice is not audible to me.
okay, sir. My coordinator, we will introduce you, sir. After 2:15, we can start after our introduction.
No issue, no issue. Okay, okay.
Thank you.
Swami sir, am I audible?
Yes, Raju sir, it is audible, sir.
వస్తుందా? శంకర్ Can you start?
Two more minutes. Two minutes in the time.
Good afternoon, all. Now let's begin our session. Sir, Suresh Babu, sir, are you there?
Yeah, I'm there. I'm there.
Yeah,
Shall I
yeah,
start?
okay. Now I would like to invite Dr. E. Suresh Babu, NIT Warangal, to share his views on permissioned blockchain using Hyperledger and use cases. Now I invite Dr. Srinivasa Raju, Associate Professor, Department of Mathematics, Geetham, Hyderabad, to introduce Dr. E. Suresh Babu, NIT Warangal.
Thank you, Shivareddy sir. It is my privilege to present the profile of Dr. E. Suresh Babu. Dr. E. Suresh Babu working as Assistant Professor, Department of Computer Science and Engineering, National Institute of Technology, Warangal. Dr. Babu obtained his PhD from JNTU Kakinada, specializing in networking and security. He secured his MTech in Computer Science and Engineering from Visvesvaraya Technological University, Belgaum, and BTech in Computer Science and Engineering from JNTU Hyderabad. Dr. Babu has 16 years of research and teaching in different levels of professor, associate, and assistant professors. In past, Dr. Babu was awarded Best Teacher Award twice for the academic years 2015 to 2016 and 2016 to 2017 at KL University, Vijayawada. Dr. Babu has held various administrative positions at KL University, Vijayawada, including Director, Associate Dean for UG and PG Research and Academic Projects, Board of Governing Body, Academic Council Member, Head of the Department of Computer Science and Engineering, and co-convener of University Technical Fest. Dr. Babu works in the area of blockchain technology, Internet of Things, IoT security, wireless networks, and wireless ad hoc network security. Some of the areas where he has contributed include DNA cryptography, MANETs, security attacks and defense measures, IoT security using blockchain. He has more than 65 referred international publications, including journals and conferences, 15 book chapters, more than 80 invited talks across India, more than 100 students lectured on networking and security related topics. Dr. Babu received CSI Academic Award entitled as Paper Presenter Award at International Conference held at CSI Annual Convention during 19th through 21st January 2018 at Science City, Kolkata, and received 2 or more Best Paper Awards at international conferences. Thank you, organizers of this FDP, for giving this opportunity. Now, I request Dr. E. Suresh Babu to deliver his talk. Thank you.
Yeah, thank you very much, sir, for introducing me. My screen is visible to all the participants?
Yes, sir. Yes, sir. It is visible, sir.
Very good afternoon. First of all, I'd like to thank the coordinator for giving the opportunity to share my knowledge on permission blockchain system. I think even I've just now gone through from last 3 days, you have come across various cryptographic primitives in blockchain and how they've been used. You come across. Today we are going to see a permission blockchain system, which is a little bit interesting aspect, and it is widely used concept, right? My session will go like this. First, we'll try to see a permission blockchain. Then we are going to have different types of permission blockchain, but we are going to discuss in detail about the Hyperledger fabric, which is widely deployed in the industry. And then the role of membership service provider, which we are going to see. For example, if you have come across various cryptographic primitives, like code-based cryptography, post-quantum cryptography, lattice-based cryptography. There are different types of cryptographic mechanisms were used already widely in the literature. Now, whether we can apply those cryptographic primitives as one of the key and essential requirement in the blockchain, where we can deploy in the membership service provider. That will try to see certificate authority and the blockchain, the shared ledger concept. I think already some of the resource persons may already covered the properties of blockchain, key properties of blockchain. One of the key property of blockchain is the shared ledger. Then we'll try to see the transaction flow in the Hyperledger fabric and how to run the distributed app on the Hyperledger fabric. We are going to discuss in detail. My voice is audible. I think I'm clear.
Yes, sir. Clear, sir.
Yeah. Thank you.
Sir, if possible, can you put a switch on your is it possible?
Sir, I'm not getting you. Your voice, I'm not getting your voice.
Sir, if possible, switch on your video, sir. Is it possible?
Yeah, it's there. No problem.
Yes.
Okay. Yeah. Right.
Thank you.
Right. Now, what are the problems we have in the centralized system? Why we are interested with the distributed system or decentralized system? If you see what are the cryptographic primitives, or if you see any cyber security issues which you are come across, they're all on centralized system, right? Now we need to go for this decentralized system. Why we are interested in blockchain and how the blockchain is going to support decentralized system. The first, we'll try to see some of the problems of centralized system. The first one is a central party will maintain the large amount of information, right? We are going to store huge amount of information at one center. For example, you see cloud, you take a cloud where it is a centralized system where we can store a large amount of information. Or if you take any traditional IT sector, they're using a large databases where they're going to store the information. The major problem with the centralized system, it will attract the hackers. Right, that's the first point which we need to aware of that. The second one is central party may be hacked, and then it will affect the millions of users. We call them as a denial of service. The service actually we need to provide to the various stakeholders. If it is hacked by the hacker, then it will affect the millions of users that you come across. Then the third problem we have is a single point of failure. If something goes wrong, at the centralized system, definitely the bigger problem we are going to face is a single point of failure, and it is not available to the stakeholders. Right. So therefore, the trend is moved from centralized system to decentralized system. Now, I want to ask a simple question to the participant. In order to see, don't mind, just I want to make you more interactive. Can you tell one centralized or distributed system which we are using now? One centralized and distributed system which you are using currently. Anyone? See, I'm audible, no? My voice is audible to all the participants, isn't it?
Yes, sir. Clear.
Yeah. Thank you. Right. See, now the question comes to you because see, if you come across internet, if you see the internet is a decentralized system or a distributed system, right? One of the best example we can come across. Now, decentralized systems are more reliable, and it will be more fault tolerant. We can say decentralized system are more reliable. If something goes wrong at one side, then immediately we can have the resources can be pulled from the other side. Next, it is more secure, and it will be more attack tolerant. That's another interesting feature we have with the decentralized system. The third one is no single bottleneck. There definitely no monopoly will be there, where will be no third party will be there, no trusted third party will be there. So therefore, no single bottleneck. It will be much faster. Next is no single point of control, no monopoly. It will be much cheaper, which we can have. So to build a total decentralized system with no central authority, the blockchain is the one way to do this. And you know that because the blockchain is a decentralized system, but with no central authority. Now, if we use a public cryptography without any central authority, definitely the blockchain is one of the container where we can use with no central authority, we can still ensure a decentralized system. Okay. So why we are going for blockchain in the sense, we are interested with the interesting point which we are interested with is the decentralized system with no central authority. Okay. Right. Now, the blockchain is ready for the business. We need to aware of that some key properties are there. I think you have come across. The first one is the shared ledger. Blockchain makes use of shared ledger. What is the meaning of that? Because the ledger will be available to all the authenticated peers or authenticated members. Then we are going to use a property called append only. We can append, but we cannot write. We cannot overwrite on that. We can append. That's the first thing. Then one of the major aspect that we are interested with the privacy. Now, blockchain is going to ensure the privacy. So therefore, the transactions will be authenticated, the transactions will be secure, and it will be easily verifiable, and even we can preserve the personal data. The third one is the consensus mechanisms or consensus protocols. Right, I think most of the participants you have come across various cryptographic primitives used in blockchain. There is another interesting research area where we can do is the consensus protocols or consensus mechanisms, which is already there. Now, what is that? All the parties agreed to the network of the verified transaction. Suppose, for example, if I submit the transaction, if I issue a transaction, now someone should take that transaction and need to validate it, need to verify it before he enters into the block. So therefore, now that concept which we are going to use based upon some consensus mechanisms. The next one which you are interested with is the smart contract. Right, it's a piece of code where it will be embedded in for each and every transaction, and it is at the time of execution, this smart contract will be invoked. Right, for example, you see this FDP program. If it is implemented in a blockchain, then immediately the instructions come, you will get from the coordinator that every participant need to attend every session without fail. Then that is a policy which has been created at the beginning of the FDP, then everyone should follow. If you are missing any one of the session, your smart contract will be invoked, and then it will be reminding that you are going to miss the session. So smart contract is a piece of code which will be running and which will be executed and along the transactions, right? The next one which we are going to have is the confidential transaction. Every transactions will be sent in a confidential way. We know that already some security properties were discussed, and you're already aware of the security properties, right? We are going to see some confidential transactions. We are not interested with cryptocurrency. We are not interested, it doesn't require any cryptocurrency principles like Bitcoin, all these things, but we are going to see the underlying technology of the Bitcoin or underlying technology of the Ethereum, underlying the technology of any cryptocurrency is a blockchain technology. That blockchain technology can be widely used for various other technologies, right? And then what we are going to see is that it is a programmable. We need to have, that's why it's a leverage the embedded logic in the smart contract to automate business process along with your network. So these are some of the key properties definitely we require in the blockchain. Now I want to have a little bit doubt. All the participants are related to the computer science and mathematical background?
Yes, sir. Yes, sir.
Yeah. Thank you, sir. Thank you. So what is this? What is the blockchain in the sense? The other name for the blockchain is the distributed ledger technology. Right? It's a distributed ledger technology, DLT. The other name for the blockchain is called as a DLT. Next one, which we are going to have, all the transactions are stored in the shared ledger. We call them as a ledger records, and it will be available to each and every authenticated node. The third one is a key value database, which we are not optional one, which we use in certain blockchains. So therefore, it is a key value database with current state as an optional. Okay. That's the third point. The fourth one is we know that it is a decentralized peer-to-peer network of nodes. Right. Due to this, we can ensure a distributed fashion. So decentralized peer-to-peer network of nodes. I can send a transaction from any person to any other person or network. The fourth one, I think you come across various cryptographic primitives, which you have come across, like if I've gone through the other resource persons, they covered various cryptographic primitives. So we are interested with public cryptography without a central authority. No one should be there. Now, blockchain will work like a distributed central authority, right? So that's a fifth property. And the sixth property is any transaction is added to the blockchain will be validated by the multiple entries. Like for example, now we are going to use a threshold signature, a threshold cryptography, where m out of n members need to validate it before it enters into the before that transaction enters into the block. So any transaction that is added will be validated by the multiple entries. For example, you see, if anyone is going to join this FDP program, someone should admit, right? Someone should admit in the coordinator. If the coordinator is a single point of failure, or if the coordinator is not available, then for example, the participant will be in the waiting room. Now, instead of that, what the coordinator will do, the coordinator will give the permission to all the 3 to 4 members. Now, 5 to 6 members, definitely they are authenticated to validate it and to enter into the blockchain. So therefore, we can say these properties will ensure the blockchain is equal to a distributed trust. The key inherited properties of the blockchain will ensure the digital trust, right? So this is all about the blockchain. I think already some of the resource persons may cover these things. Just I'm going to give an overview of this blockchain. Okay. Now I request the participant, please go through this definition. And I'll ask 1 or 2 queries regarding this definition. A single linked chain of blocks of verified signed transactions that is replicated globally on the millions of nodes. Now, if you see here, this definition will give a lot of analysis, a lot of analysis to be there. The first one is single linked chain of blocks. Now, each block may consist of set of transactions, and all the blocks, whatever we are going to store into the chain, they need to be verified, and it should be signed by the issuer of the transaction. And these verified blocks will be replicated globally on the millions of nodes as a shared ledger. Therefore, one more important point we are going to use called hash pointer. Each and every block is linked with the hash pointer. Right? Now, what are the cryptographic primitives we use here? Can anyone tell me? What are the cryptographic primitives we are going to use in this definition? Okay, good. Okay, sir. Hash function is one. Any other? Any other? Let's make this session a more interactive session rather than passive mode of learning. Passive mode of learning in the sense, I'm going to, after the lunch, sitting in front of a system or mobile, it's very difficult listening to that, isn't it? So therefore, I request the participants be more active so that you will feel a lot of comfortable in listening to the session. What are the other cryptographic primitives we have here? Okay, no problem. So we are going to use verified and signed, which we call them as what are public key cryptography. We'll try to use, because if anyone wants to sign the transaction, someone should verify the transaction. So definitely this property is, we are going to use one more cryptographic primitive called a public key cryptography. Therefore, you have come across various public key cryptographies which we can apply in the blockchain, right? Very good, sir. Now what we are going to have block 0, block 1, block 2, block 3, and block n. Now each block will have set of transactions, and this block will have set of transactions, this block will have set of transactions, this block will have set of transactions, and will link with the help of the hash point. Okay. Now if anyone want to change any block or any transaction, it need to change. And definitely it's very difficult to hack, or it is very difficult to change. So therefore, blockchain itself will provide the enhanced security. So definitely we can say it has a built-in cybersecurity issues can be resolved using the blockchain. But it is very difficult to say because it is very early to say that a blockchain is going to provide all the solutions to the cybersecurity. Now, this is how the blockchain will work. I think you've already seen this diagram previously. Just I want to quickly review this diagram. Now, if you observe carefully, this is a transaction. This is one block we are talking about. This is one block we can have. This is a whole one block, and each block will have set of transactions. It's already covered. This diagram, I mean, blockchain basics is already covered by any other resource person.
Yes, sir. Today in morning also, even Nilanjan Banerjee also covered some basics in blockchain, sir.
Right. Then rather than explaining once again, I'll ask the participants to answer. Now, what are the key properties we can ensure? One is public key cryptography we can have, right? We can use a digital signature. The first important property is the digital signature and the hash pointer we are going to have. Now, what are the key properties that this blockchain will help you in the sense? One is we are going to use owner's identity, right? Your public key will work like a owner's identity. Identity management will play a key role here. The second one is a tamper proof. Hash function is mainly used for the tamper proof. Now, we are interested how the tamper proof can be ensured using the hash point, right? So these are the two important key properties that we need to apply for any blockchain. And then we are going to have old owner signature, because the major thing we are interested, suppose for example, whenever the information is flowing from one person to another person, the end person who have received the information from the intermediate node should know from where this information has been received. Who is the source node? So therefore, we need to know the signatures of all the people from where the information is flowing from one person to other person. So the blockchain is going to help in such factors, right? So therefore, quickly we'll try to see, do you have any doubts? Participants, do you have any doubts up to this one? Okay, thank you. Now, how to find and transfer a block or transfer a new block which we would have. Now, we are assuming that we are going to have one transaction. That A is sending some transaction to B. That A is going to send some transaction to B. And some X is going to send some transaction. Some Z is sending some transaction. B is sending some transaction. And D is sending some transaction. Now, all the transactions, we need to form a block. All the transactions, we need to form a block. And this block need to validate by someone. So we are going to use node is going to validate the block, and this block will enter into the chain. Now, there are some internal processes were there. See, theoretically, it is very easy to explain the blockchain, but when it comes to practically, it's a lot of things need to be considered, right? Whether this transaction has a valid transaction, it has a valid signature, whether the public key is already available, so that we can verify it. So all these three issues need to be considered before we enter that block into the chain. So therefore, we need to know how to find a new block or how to add a new block into the chain. Now, how the distributed ledger work in blockchain, just quickly we'll try to see here before I go into the permission blockchain. Now, user is going to initiate the transaction. Whenever he want to perform some transaction, he will initiate the transaction using the digital signature. You can apply the most popular digital signatures we have in the literature. We can use currently the digital signature which we're using is the elliptical digital signature algorithm, which you're going to use it. User is going to initiate the transaction with the digital signature. That is step number one. Step number two is the user is going to broadcast, after doing the digital signature, is going to broadcast their transaction to the nodes in a P2P fashion. One or more node, which we are going to see here, one or more node began validating each transaction. That is number, means we need to validate the transaction, whether it is a valid one, whether it has been verified successfully or not. And then the transaction is going to combine in a block with the other transactions, which are coming from the various user. That is step number 4. The step number 5 is one node who have some special characteristics is going to aggregate the validated transactions into a block. Someone should be there to collect all the transactions and you need to form a block. Step number 6, a node is going to broadcast that block to all the members in the blockchain. Step number 7, we need to follow the consensus mechanism need to be ensured. Consensus protocols need to be there, means we need to whether everyone is followed the same agreement or not. And then we are going to reflect that block into the chain. That is step number 8. So this is the way how the distributed ledger work in the blockchain, and it's going to store the data, the information which we are going to message into the blockchain. Right. Now, so this is the general part of blockchain you have come across and you already see. Now we do have different types of blockchain that are available in the market. Now we'll try to see the types of blockchains that are available in the market. They have been classified based upon certain principles or based on certain characteristics. One is implementation design. First of all, we need to consider what type of implementation design you require in order to implement a blockchain. The second one, which we are interested with, the administration rules. Suppose, for example, now I want to know, assume that Geetham University is a big university where major people will, the student strength and faculty strength will be very huge. Now, if they want to implement a transparency among the students, among the parents, among the staff, among all other members, then we need to follow some administration rules, need to be there, need to be incorporated into the blockchain, right? And that whatever data to be available, suppose, for example, whatever the information which we are passing to the faculty, that information should not be available to the students. We need to restrict it to only faculty, right? What data available, whether data should be available to all the members or only to the certain peers. In such cases, we need to know whatever data availability is there and what are the various access privileges. Depending upon all these categories, we are going to classify the blockchain. So there are 4 different types of blockchains we have in the market to classify. The first one is a public blockchain. The second one is a private blockchain. The third one is permissionless blockchain. And the fourth one is a permission blockchain. We are going to have different types of blockchains which are widely available in the market. Now, I request all the participants, please go through this. Please read it carefully and understand whatever blockchains you come across. See, public blockchain, the first one which I told. The second one is private blockchain. The third one is permissionless blockchain. The fourth one is permission. I request each and every participant, please go through all these 4 categories. Yeah. Gone through? You have followed?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Now, see, as the name suggests, that public blockchain or internet blockchain, we can call them as. Right? There is no restriction on reading the data as well as writing the transactions or writing the data into the blockchain. That there is no restriction. Anyone can include and anyone can write it. That's all. The second one is a little bit interesting, private blockchain. For certain applications, we want to have some restrictions. So a blockchain that is going to allow the direct access to the data, sorry, go back, direct access to the data and the transaction submission only to the predefined list of entities. Suppose, for example, you take this FDP program. Now, see on what basis the participants were selected means there will be certain criteria, right? There will be certain criteria. The coordinator will follow the criteria which is given by the guidelines of the university as well as by the sponsored agency. So based upon that, is going to choose, the coordinator is going to choose the list of members. Now, for those people only, they whatever the sessions they want to listen and whatever they want to access, they can access. Means we can say that only to the predefined list of entities who are already authorized, who are already authenticated. Only those people are allowed to listen the lecture classes from Monday to Friday or Saturday. That's, we call them as a private blockchain. We need to implement a private blockchain there. Next one is a permissionless blockchain. In permissionless blockchain, there is no restriction on the identities. Now, we need to create the identities of the transaction process. There is no restriction. That's why it's called as a permissionless. Whereas permission, which we are going to discuss in detail today, is permission blockchain that is going to allow the transactions processing only to the predefined list of subjects with the known identities, because their identities will be known before they perform any type of operation. We call them as what? A known identities. Right? Now, therefore, first of all, you need to prove yourself. Whether you've been working in some institute or not. If you're working in an institute, definitely you need to give your credentials. You need to fill the application and you need to give the signature from the institution, and then you need to submit that soft copy or a hard copy with a digital signature. You need to send to the coordinator. Coordinator is going to validate it. So then he will assign the one FDP ID to you. So that based upon that FDP ID only, you are going to allow to attend this FDP program. Okay. So we call them as what? Permission blockchain. Now, so this we will try to see quickly what is the difference between the permission and permissionless blockchain. Permissionless blockchain is open, but there is no restriction in number of blocks, number of transactions in each block. Whereas permission is a closed one we can have. The ledger design is only one ledger. Here we can have either one ledger or segregated ledgers. We can have more than one ledger also, which can be used. And validation we use mainly depends upon the degree of trust between the nodes. Now we need to ensure the degree of trust between the nodes. That is one of the key requirement, especially for both permission and permissionless blockchain. Where there is no basis for the trust, there may be achieved using the proof of work. In the Bitcoin, we call them as what? Proof of work. Means you need to prove that you're going to work for certain things and you're going to claim some intensives. Your computational power will come into the picture, which requires that we call them as algorithmic solving of the cryptographic hash. Can anyone tell me about this one something? I want to know how we are going to have. We are going to use some nonce and then we are going to generate that cryptographic hash. Can anyone tell me something about this? See, for example, I'll give a small example too. Suppose, for example, now we have for this FD program, 67 participants were there. Now I want to know whether all the participants are sincere and honest and they're listening this session. I want to know. So I don't want to know because I don't have any trust in this online FDBs. Why? In the sense, because the people I've seen from last 2 years, I'm not criticizing any faculty here, please. just an example only I'm telling. This you take as a case study. Now, what is happening in the sense in the online FDPs, people will join and they will mute, they will not, we can't see your video, and they will go and they will do some work, right? That's the case which is happening in major cases, now, how to identify as a coordinator or as a resource person, how to identify how the people, whether they're listening or not. Now, there is some proof of work is required. Now, I'll ask a question. Now, whoever are responding, definitely I can come to know that they're listening the class, they're using some resources, and they're answering. That I can say that yes, these faculty are very active, and they have been proved they are there from last 45 minutes, right? So if I want to know that, for example, if the people are not there, not there in the DP session, then I'll ask the coordinator, sir, I'm going to give certain assignments. You try to give this assignment to the people who have not attended, who are not active for this session. We call them as what? They need to complete this assignment within the stipulated time. So that we call them as, again, another example of proof of work, right? So definitely we need to know this proof of work is one of the interesting concept which is available in the Bitcoin. It has different meaning. All right, I'm given an example to understand for that. Yeah. So what we are going to see here, a proof of work will require the algorithmic. Suppose if I'm going to change something, it need to have the relevant hash value. Generating the nonce and equivalent hash value need to be generated. That is a cryptographically hard problem, and it is very difficult to generate, to have the proof of work. Then the consensus mechanisms which we are going to use, mechanism is going to it depends upon the degree of trust between the nodes we have. And then there is no central authority. The consensus may be determined algorithmically, which you can have. So this is the difference between, yeah. Do you have any doubt?
No, sir. Continue, sir. No, sir. There is no participant, right? Sir, you can continue, sir.
Okay. Someone is, I think, maybe there. Right. Okay. Now, see, in summary, to conclude, the permission blockchains, we call them as what? Public blockchains. They're commonly referred as public blockchains. Permission private blockchains are usually referred as fully private blockchains we have. Now, I request you can see permission public, permission public, permissionless public, permissionless private, and permission private, which you can have it. So therefore, we can use a decentralized peer-to-peer network, decentralized organization, intra-organization network, organization restricted ledgers, which you could have it. Now we are going to see there are some different types of blockchain platforms which are available in the literature. Now we are going to discuss one of the interesting permission private blockchain is the Hyperledger fabric. That we are going to study in today's session. Okay. Right. Participants, do you have any doubts up to this?
Yes, sir. So, sir, in the last slides where you have shown the difference between the permission and permissionless, so there is a feature that is validation and consensus mechanism. So both are same or different? Validation or consensus mechanism? Validation and consensus mechanism.
Yeah.
So both are same basically.
Consensus and
validation.
Both are same, you mean to say?
Yes, sir. I was just want to ask, both are same or not?
No, both are not same.
Okay, because here you are right, methodology depends on degree of trust. That's why I'm asking.
See, please come once again. Your voice is, I think, a little bit low.
Okay, sir. So both are not same. So can you explain me how they are different?
Yeah, right. Let me see this, for example. Now, you see, validation is something like, for example, in certain cases, I want to do some validation. Suppose, for example, Now, public keys, if you take in IoT devices, we are going to have some millions of devices which you're going to have. Now, assigning the IP addresses, IPv6 addresses for those devices, it's a very difficult task. Now, what we are going to do, for example, you see, I'll give an example only to understand in detail to see that. Now, we are going to use a Bluetooth. Now, in the Bluetooth, what we are going to see here, we are going to have a master and slave concept, right? One person will be a master who is going to initiate, other persons will be a slave. Now, here, the master will become a validator. He is going to maintain all the slaves. We can have maximum Bluetooth, we can have 7 slaves can be stored. All the 7 slaves, passwords will be stored by the master. Now, master is going to validate, please ensure the master is going to validate all the slaves, right? Assume we have another Bluetooth network. Now, this Bluetooth network, again, is going to maintain 7 slaves. And these 7 slaves is going to maintain by this master 2, M2. And here, the other Bluetooth network will be maintained by master 1. Now, these 2 fellows will validate the slaves. And if we are creating a blockchain here between M1 and M2, then what is going to happen? A slave can be a slave of a master of one network, can communicate with the slave of the another network in the blockchain between the validators of M1 and M2. This is a validation which you're going to do it. You're able to get it?
Yes, sir.
Now, what we are going to use, we need to follow some consensus. Consensus is nothing but agreement. Now, agreement need to be there between M1 and M2. Both need to agree, right? They are forming a network, and then certain policies need to be there with respect to the Bluetooth in order to communicate from M1 to M2. Those consensus mechanisms need to deploy, and it varies from application to application. Validation will follow the consensus mechanisms. Lalit, you are able to get it?
Yes, sir.
Yeah.
I got it.
Right. Any other doubts from the participants? Okay, thank you. Now we are going to see one of the interesting one called permission blockchain. Right. In the context of permission blockchain, I think if you come across one of the interesting properties or design principles or design choices of Bitcoin, it has some unique properties. Like it has a transparency, it is a decentralized peer-to-peer network of nodes, it has public cryptography without central authority, it is a distributed shared ledger. So some key properties are already available and it is already proved as a better choice. Better choice, and it is widely used in the market. Now, if you want to implement same design choices of Bitcoin for some other applications, definitely it is very, very, very challenging. Now you see, now why? Because the design choices of the Bitcoin protocol becomes non-essential. For example, you see, we are going to use a proof of work consensus protocol, which is mainly suited for the cryptocurrency protocol. Right, this mainly solves the problem of Sybil attack. The identity problem can be overcome with the help of the Sybil attack, or distributed denial of service attack can be easily overcome using the proof of work mechanism. Right now, whereas in our case in permission blockchain, which I told in permission blockchain on what property it is going to work. Can anyone? On what property the permission blockchain will work? Just now we covered. See, I told you predefined list of identities based upon, because already I know your identity, right? I already know your identity in blockchain, because before we entered into the network, your right? Your identity will be known, right? Yes, proof of authority, which you're going to use it, that we call them as what? Proof of identity will be known, right? So therefore, we don't require this proof of work consensus mechanisms, especially in the permission blockchain. That's the first property. The second one, right? So because it is supported with known identities, so we definitely with known identities we can have a simple attack resistant consensus becomes unnecessary here. And instead of that, we can use threshold signature schemes. I'm not discussing in detail about these threshold signatures. If you're interested, we can go for threshold signatures, which can be used as one of the key important parameter as a consensus mechanism. Is now rather than now we need to validate it. How many people will validate it? Now we need to know m out of n. M out of n members need to verify or need to validate the signatures. Need to verify the signatures. So then only we can enter that transaction or that block into the chain that we are going to use as a threshold signature scheme. Okay. Now, how can we use this permission blockchain using Hyperledger? That's we are going to see now. Now, this is a little bit interesting one. Why we are interested with Hyperledger? The first one is it is maintained by the Linux Foundation, and it's one of the important one is the open source, which is freely available for you to design to implement your own application. And it is introduced in 2015. It's an open source, open standard, and open governance will be there. Major industries were part of this fabric design, which you're going to have it. It's to advance the cross-industry blockchain technology. And the Hyperledger we are using, it is used as a permission blockchain. The Hyperledger is used as a permission blockchain. It has some key properties because it uses secure previous architecture and driving more scalability, and secure architecture is already taken as a secure architecture. It provides better privacy and better identity management. So therefore, the Hyperledger has some key properties. One is it is making use of a pre-known proved architecture. It is more scalable and secure architecture, privacy, and better identity management. There are different types of Hyperledgers were there in the market, which you can have it. Now, Composer, Fabric, Indie, Ira, and Sawtooth were there. Now they have their own use on their own applications. Now we'll try to discuss one of the interesting one, which can be used widely for various technologies. In this session, we are going to discuss about the Hyperledger Fabric. These are some of the Hyperledger members, main contributors, premier organizations, general organizations, which are there, and associate organizations with there, which are contributing to the Hyperledger Fabric, to the Hyperledger members. I don't think you required, even you can do some installation process because time is only 1.5 hours and we are going a little bit low. Shall I skip this installation process? Yeah. If you want video, I'll give the video to you. It will take some time, maybe a few minutes of time will be taken to you. So therefore, I'm going to skip this video to how the Hyperledger Fabric can be there. All right. Now we'll try to see. We are assuming that we already know the installation process of the Hyperledger Fabric. Now, what are the key platforms, key properties that Hyperledger Fabric has? Now, see, when we talk about Hyperledger Fabric, it's a distributed ledger platform. Now, all the key properties that are already available, and it emphasizes on shared ledger, smart contract, we call them as a chain code, consensus mechanisms with there. We are going to use here a raft consensus mechanism. Confidentiality will be there, resiliency will be there, and better scalability is going to provide. So because of these key inheritance, key factors, key properties that are there in the Hyperledger fabric. Okay. As already told you, it includes the ledger, which makes use of smart contract. In our terminology, we call them as what? Chain code. Chain code, where we can participants can manage the transactions, and it has some pluggable options because it supports the data can be stored in multiple formats, which is why therefore it is widely used. Switchable consensus mechanism, right? Previously, it has different types of consensus mechanisms were there. Right now, currently we are going to use a raft mechanism, which you're going to use, right? And it offers the ability to create the channel. For example, you see, now from one organization to another organization, and from this organization to this organization, we can create the channel so that we can communicate, right, separate with the without involving the other person. So organization 1, organization 2, organization 3. Now, organization 1 can communicate with organization 2 without sharing to the organization 3. Organization 1 can communicate with the 3, but without sharing to 2. And 3 can share to 2 without sharing to 1. With the help of these separate channels, we can have it, right? So that's a property. It offers the ability to create the channel, which can ensure the trust. It allows the group of participants to create a separate ledger. Just now I told you, no, it can create a ledger 1, a ledger 2, and ledger 3 can be created as per the requirement of the specific application. Now, this is a Hyperledger fabric with the blockchain. We can have organization 1, organization 2, organization 3, organization 4, organization 5, and organization 6. We are going to have a different Hyperledger fabric organization network, which are formed a distributed network. Now, this is a simplified fabric blockchain network. Now, I want to have certain important properties you come across from last 3 to 4 days, right? You heard about CA, Certificate Authority, or Centralized Authority, sorry, not certificate, Centralized Authority. What is that, Lalit sir? What is that certificate authority responsibilities?
Are you asking about certificate or central authority?
It's a certificate authority. Sorry,
Certificate.
centralized authority. Centralized authority.
Centralized authority, example, in the case of the transactions that we have a bank, that is a central authority.
No, I'm talking central, right? Centralized authority. What is the role there? I must.
They basically maintain the transaction.
Right. In public key cryptography, we have a certificate authority. In public key cryptography, we are using a concept of certificate authority.
Yes.
Now, what is that?
The certificate authority basically maintain the which kind of digital signatures are used, hash algorithms are used. They will define that.
No, actually, all right. Maybe little bit ambiguity is there. Right. Good. Good, Lalit. I think you have more. I mean, appropriate. You're good. You are giving the good answer. But you see here, for example, we have the problem of how to distribute the public keys to all the members. Now, if I want to give my public key to you, someone should be there who can monitor me and who can send the public key on behalf of me. Right? We need to trust someone because distribution of public keys is the biggest factor we have. Right? Now, the distribution of a symmetric key or the distribution of the symmetric key that can be overcome with the public key cryptography. But public key cryptography, again, it has certain problems. How to distribute the private public keys? Right? That need to be resolved by the certificate authority which you're going to have. Right? Or we can also call as a centralized authority. Now, here in our case, we are going to use some end user. We are going to have some end user in the blockchain. Sorry. And we call them as a client, and we are going to use some peers, and then a CA will be there who is going to issue the keys. the public and private keys to the members of that organization, to the member A, right? And then we are going to have a network operator. Here we are going to use the concept of orderer. I'll tell you these words in the coming slides. Orderer, who is going to do some ordering. And here we are going to have the CA. And then this is the member B, where we can have the client and CA and some peers will be available. Right? So in order to have a communication from this end user to this end user, the end user of organization A need to communicate with the member of the end user of B, organization B. Need to be communicated via network operator. Okay. So this is a secure architecture we have in the Hyperledger. In one of the important key factor we have is the membership service provider. Under this category, we need to know identity management, we need to know authentication management, authorization service, and certificate management need to be maintained by the MSP. Now, what are the cryptographic primitives used in the blockchain or you have come across in the blockchain? We can use those things in the Hyperledger as a membership service provider. Then we are going to have a smart contract, like lifecycle management, transaction validation, execution engine, and event dispatcher will be taken care in the smart contract. A smart contract is a piece of code that will be executed and it will be validated at the time of transaction execution. Then third one is the distributed ledger. We are going to use the peer-to-peer communication. Consensus mechanisms will be used. Cryptographic primitives will be used, and the storage ledger we are going to use it. So this is the architecture, Hyperledger fabric architecture, that we are going to use various components for any type of application. So this is a simplified one. I request the participants, please go through, which I did just now. I told you, membership services for auditing purpose, authentication purpose, identification purpose, public key infrastructure can be maintained. And then what are the blockchain services it is going to provide? Peer-to-peer mechanism, a distributed ledger, shared ledger storage, and consensus protocols which you're going to use it. And smart contract, we call them as what? The chain code services, which we are going to use secure container and secure registry can be there that will be executed at each and every transaction. Okay. Now, in Hyperledger, we are going to use a shared ledger that consists of two components. One is the old state, the other one is the transaction log. Now, old state describes the state of the ledger at any given point of time. It's a database. And transaction log, it is going to maintain, like it is there in the DBMS, I think you already come across. It is going to record all the transactions, right, which have been resulted in the current value of the world state. The transaction log will be maintained along with the world state, which is in the form of shared ledger. We are going to use different types of ledgers we can use, and the database like MongoDB, OHDB will be there. So a ledger has a replaceable data storage of the world state can be used. By default, it is going to use the OHDB. If you want to store, we can use as a OHDB. Okay. Now, I request the participants, please look this diagram. You'll come to know. If you see, now blockchain developer first need to write the smart contract through via client application is going to submit a smart contract, and the smart contract will execute the transaction, and then it is going to store either in the blockchain or in the world state. Put, get, and delete operation will be done before we enter into the chain. So this is the way how the application, end user application, is going to interact with the blockchain. Okay. So working with the ledger, how it is going to work in the ledger in the sense, this is an application. This is a smart contract. This is a world state. And this is the transactions with the set of blocks we have. Right? Now, what is that? It is there. We need to write is the transaction input. I want to invoke my smart contract. I want to set the owner, my car, with the name called Matt. And then smart contract is nothing but what? Smart contract implementation will do that, will execute that transaction. It will verify the identities, or it will verify the credentials, which is already stored for that particular owner. And then it will, once it is there, then it is going to create the world state with new content. My car, right? With my car VIN is 1234, owner is Matt, and the car is Audi car. It is going to store the whole information in the world state, and then once it is validated, it will enter into the block. Are you able to follow?
Yes, sir.
Yes, ma'am. Thank you.
Yes, sir.
Yeah, thank you. Thank you. Now, we are going to see one of the key requirement, especially identity management. Now, how can we apply this identity management, which is very, very interesting one. It is one of the key research. As Hyperledger Fabric is a permission, any new member of the network should enroll through the MSB service. Means, first of all, if you want to register, first of all, at the time of registration process itself, you need to get the public key and private key as well as the blockchain ID or ID. That ID will be known to the end user as well as to the blockchain or members of the blockchain, right? So the new member of the network enroll through the MSB. We call them as what? Membership Service Provider. Now, who are the actors in the blockchain? In the sense, we are having different types of actors. Like, for example, we can create a issuer, we can have a recipient, we can have some company, and in blockchain we are going to use endorsers. Endorser is a special pair who's going to do some validation. Endorser pair, orderer, ordering of transactions one after the other, right? All the members, what the responsibility is, first they need to register to the MSB. They need to register to the MSB. Everyone need to register. Any new, even see the coordinator of this FDP program also need to be registered first, right? Not only you, even the principal, vice chancellor, anyone need to register first before they want to access this FDP program. Okay, so that can be done using the MSB, Membership Service Provider. Now, already you come across, especially while studying the modern cryptography, we have this. I think you'll come across this. We are going to have some centralized authority. We in the centralized authority is nothing but we are going to use certificate authority. CA is a certificate authority. Under this category, we are going to have different types of authorities like registration authority, enrollment authority, transaction authority, and TLS authority, because the transaction which will be signed that need to be validated by all the members of the network or verified by all the members through TLS certificate. Now, registration authority will generate R certificate. Enrollment certificate will be generated by the E-cert. Transaction certificate will be generated by the T-cert, and TLS will be validated by the networking, mainly for the TLS, transport layer security certificate, which is the TLS certificate. Okay. Now that's a point. We are going to use enrollment certificate, which is a long-term identity, which will use it for a longer duration of time. Transaction certificate will be a disposable certificate, typically used once, because whoever want to issue the certificate, they need to have a transaction certificate and it will be used only once. That's why it's called as a disposable certificate, typically used one time and requested will be done from the transaction CA. All right. Permission interactions will be done either from E-cert or T-cert. Enrollment certificate or transaction certificate will be done. So these are all the cryptographic primitives which we are going to already, which we are use, especially the literature. They are already applied practically in the blockchain. Okay. Now, if you observe here carefully, we have certain interesting properties. We have this is the E-cert and T-cert, which will be linked together for a user. This is a Fabric CA. Root authority will be there, and then some key properties were there. Clustered database, authenticated enroll ID and a secret will be generated, and it will be stored in LDAP. And then hardware security module will be there, will be stored in your computer once it is stored. Once you will get the credentials from the fabric C. So that's a point we need to know. E-cert is for long-term identity. T-cert is a disposable which can be used only one time. And we are using LD AP, which we call them as what? Lightweight Directory Access Protocol for user authentication. For user authentication. And then we are going to use the HSM, which is called as a hardware security model. These are all some of the key properties we have in the fabric C. Okay, which is a very, very, very important. So this is a registration enrollment using the membership service provider. We are going to use it. Every member, whatever we are who want to register, they need to go to the registration authority. Once the registration authority will be there, it will generate RCert. RCert will be sent to the enrollment certificate authority. Then it will generate eCert. Then again, if you want to do any transaction, if you need to restrict, you need to get the permission from a transaction certificate authority, where you will get the T-cert, and then for a networking is going to get the TLS certificate authority. Okay. Now this is a process which we are going to have it. See, step number 1, what is that? Enroll ID. You will request, the client application will request for enroll ID, register enroll ID. And from the CA, what you will get some secret. One-time secret, we are going to get it. Now, using that secret, now what is going to send? Eve is going to send the enrollment ID along with the secret to the blockchain user. To the blockchain user. Blockchain user is going to maintain the wallet where he will get the ECET and TCET. ECET and TCET. From where he is going to get ECET and TCET? First, the blockchain user SDK application, client application, request to enroll by sending the credentials enrollment ID along with the secret, so that he will get the response as an ECET certificate, which is signed by the enrollment certificate authority. Therefore, that ECET will be there. Again, if you want to send the transaction, if you want to perform any transaction, once again is going to generate the T-cert. T-cert will be generated and you will return the ECET. And this ECET and the T-cert will be there with the end user, so that he can perform in future any type of transactions. This is the way how the two users were using it in the membership service provider. See, now using that enrolling certificate request through the MSB, MS certificate authority will generate ECET as well as TCET. There will be a link will be there between the ECET and TCET. Once it is going to get it, and then this fellow is going to enter into the blockchain, and this fellow can verify the blockchain. User A is going to enter the transaction, and user B can verify the transactions like this. We can. So that can be done using the MSB. Membership service provider is one of the key requirement in the Hyperledger fabric. The cryptographic primitives which you come across, all these things will be used in the MSP, membership service provider. So that's why request the certificate, issue the certificate. We are going to store, sign and encrypt the transaction, and then verify and decrypt the transaction that everyone should be registered into the blockchain. Okay. So do you have any doubts here? Okay. Now we are going to use certain key properties were used in the Hyperledger fabric. If you take an organization, here we are going to have the organization here. This is an organization we have. On the organizations, we have peers, we have a CA, we have endorsing peers who is going to validate our transaction, who is going to sign our transactions, who is going to verify the transactions. Here, this is our organization we have. This is another peer, endorsing peer will be there. And then CA2 will be there for this organization. This is one organization, this is another organization we have. So what is that we are going to use? It's a committing peer. who's going to maintain the ledger as well as the state. Ledger as well as the state. Right, and then is the person who is going to do a committing peer is called as a committing the transactions. He is going to commit the transaction, and he may hold the smart contract that we call them as a chain code. Whereas endorsing peers are also a specialized computing peers that are going to receive the proposal transactions and for endorsement. He is going to accept the transaction or deny the transaction. Means he can accept the transaction or deny the transactions. That can be done, and must hold the smart contract. The two persons will hold the smart contract. Next, third one is ordering peers. This fellow is going to approve the transaction block into the ledger, right? And it communicates with the committing peer as well as endorser peers. This is a person who is going to do coordinating the committing peers and as well as endorsing peers. But it does not hold the smart contract or chain code, and it does not hold the ledger. Does not hold the ledger. So these are the key requirements of, and these are the three different roles we have in committing notes, ordering peers, and endorsing peers. Okay. I'll go a little bit on 1 minute. I'll try to see here. Yeah, I'll try to tell you how these things will be there. Yes, we are short of time. Now, if you see here how it is going to happen, in the sense we are going to have the execution phase, ordering phase, validation, and persistent storage. Now we are going to see here, please listen, this is a user 1 we call them as, and here we call them as the endorser. E1 is nothing but endorser, E0, E1, E2, endorsers will be there. Now what the endorser will do, now he will propose the transaction. If you want to send a transaction, he will propose the transaction. So user 1 will send the transaction to E0, E1, and E2. So propose the transaction. Now what E1 will do is E0, E1 will do, they will execute that transaction. That's why they will execute the proposed transaction. None of these transactions will update the ledger. They will not update the ledger. They will verify, they will validate it. They will see the credentials. They will see the E-cert. They will see the T-cert. All these things will be done by executing. The endorser peer will execute the transaction. Step number 2. Step number 3 is they are going to send the endorsement back to the client. We call them as what? Proposal response back to the client, right? Which is signed by the 3 endorsers. Now, once the 3 endorsers receives this one, then the client will send that the signed transaction, which is signed by the endorsers, will send to the blockchain for ordering. Now, this fellow is the order, because again, you see other applications also sending the transactions. Other applications are also sending the transaction along with the transaction. The orderer will collect the ordering of transaction 1, 2, 3, and he will create a block. He will create a block once it is validated, once it is verified. Now you see, the orderer will send back the transaction to E0, E1, E2. Now you assume that here, please assume that P3 and P4, whether they have received they have received the request from the client. Transaction response they have received from the client, or only E1, E0, E2 received the request. So E1, E2, E3 only received the request from the client. P3 and P4 are committing peers, but they have not received the request. But they will trust the P3 and P4, they will trust E0, E1, E2. Right? So that is based upon the consensus mechanism or ordering algorithms which we are using. So currently they use Solo or Kafka is a crash fault tolerance algorithm. So therefore, only P3 and P4, they will take as a ledger, they will take the transaction, but they don't know, right? They have not created any validation. Okay. Only E0, E1, E2 are validate the endorsement, validated the transactions. Once it is validated, then all the E0, E1, E2, P3 and P4 are validated the transaction. And once validation is happened, then it will enter into the block, and that notification will send back to the user that your transaction is successfully registered in a block, and it will be added to the ledger. So this is a way how the permission blockchain is going to be worked. Will notify the publications. I think we are running short of time. It's very difficult to explain the use cases. Sir, Swami sir, you are there? Sir, any time is there to explain, or because next session will start, no?
Yes, sir. Yes, sir. We have time, sir. We have almost more than half an hour. We have, sir.
Oh. No, up to 1:30 or 2 o'clock. My session, my session will be up to 4 or 3:30, sir. Okay, let me explain this.
More than 30 minutes we have, sir.
No, we have time, no?
Yes, sir.
My session is up to 3:30, sir, or 4 o'clock. I won't.
Up to 4:15, sir. But last half an hour, you can take it as a question and answer hour, sir.
Up to 4:15, my session.
Yes, sir. You can take up to 4, sir. 4.
4, okay. I thought up to 3:30 only.
Okay, sir. Up to 4 you can take.
Okay, right. Right, now running the DApp on the Hyperledger Fabric, how we are going to do in the sense, let me see before we go to the use cases. Now we are going to have the user, this is the user A and this is user B. And then we are going to have a backend API. This is also a backend API where you will get the credentials. The public key and private keys will be stored here. Now, once it is there, this is the part of the MSB, which I told you, membership service provider. Now, whoever want to send the transaction proposal, the transaction proposal will send to the endosers. This transaction proposal will be sent to the endoser. Endoser will execute the transaction proposal, right? And then all this is blockchain. This is a blockchain where they will maintain the peers. It can be committing peers or it can be endorsing peers. And here we will do the ordering service. Now we'll try to see how we are going to run this DApp on the Hyperledger Fabric. Now assume that we are going to have the ordination 1, ordination 2, ordination 3. Ordination 1, ordination 2, and ordination 3. Now these are the 3 ordinations we have. Okay, now what we are going to do, the users, they are going to interact with the user interfaces with the SDK through it can be through web or mobile, they're going to have it. So this is the one user, they're going to be interacting. They're going to be interacting, right? Next thing is here, then through REST API, they are going to connect it to the client application through some Node.js or Java. Through the client application, they are going to be accessed. As already told you, know, LDAP. Okay. Then this is a Hyperledger Fabric peer. this Hyperledger Fabric Peer, this Hyperledger Fabric Peer. And then this ordering service, Hyperledger ordering service will be there at the end level, where you can do the ordering service. And then you see all the members will be communicating with the service, ordering service will be there, ordering service will be there. And in this ordering service, they're going to have some endorsing peers as well as committing peers will be there, where they will maintain a blockchain with a set of transactions, a blockchain with a set of the blocks which you're going to have. Okay. Next one is this is the chain content, the chain code container. We call them as a smart contract. So that's why peer perform the specific application by executing the smart contract, right? We call them as a chain code. A chain code is application specific. We are going to write a piece of code on the chain code, and then it is going to run on each and every transaction on within the peer. We are having different types of chain codes out there, sir. So like a system chain code will be there, channel chain code will be there, peer chain code will be there, transaction chain code will be there. Different chain codes which you're going to use in the Hyperledger Fabric. This is a chain code where it will go, it's something like a smart contract. Okay. And then you see, we are going to have MSP who's going to maintain the Hyperledger Fabric CA. This is Hyperledger Fabric CA, and this is Hyperledger Fabric CA, and this is external CA, which will be covered, which will be monitored in a hierarchical fashion. And then they're going to monitor by all the peers. And this is the consensus mechanism, where it will do a network level service for determining the order in which the transactions are coming from the various end users who are issuing the transactions, and they need to store into the blockchain. Currently, they use Kafka. Previously, they used the Kafka. Now they are using the Raft cluster mechanism, a Raft consensus mechanism. Okay. So this is the final conceptual level of the architecture of the Hyperledger. Or you can create any type of an application once you are clear with the terminology, once you are clear with the concepts, then you can create any type of an Hyperledger Fabric application. Okay, now we'll try to see which we did as a case study. Students have did this one. Let me explain in detail about this one. So actually, what is the problem now we are facing, especially in the universities? The major problem, how to eradicate fake certificates. Because now it's the biggest problem we have, the fake certificates will be there. That's the first problem. Second problem is like the university, like a Geetham University, where large number of people will be there. They'll maybe from in a year 5,000 to 6,000 students that are going to leave the campus. Now the biggest challenge, especially for the administrator, whenever the student leaves the campus, they will have the certificate. Those certificates will be submitted in the respected companies by the students, and the company people, they will send the certificate for verification. Due to their busy schedule, the administrator may be delayed, right? The delay can be happen so that the student can lose the job also. Now, how to solve this problem? How to eradicate the eradicate the fake certificate? That's one problem. The second problem we have is how to verify the certificates very effectively without any delay. So this problem can be overcome when we want to apply the academic digital certificate using the blockchain. You got the problem statement, all of you? You're able to follow me?
Yes, sir.
Yeah. Now you see here, now we have one organization. This is one organization. Sorry. This is one organization. This is another organization we have. This is another organization we have. This is another organization. One organization which we can have for the students. Another organization is for the institute. Another organization is for the company. And we are going to create a channel, a common channel will be created, or a separate channel will be created for various organizations. And then we are going to have the ordering service. And each organizations, we have committing piece, endorsing piece, and normal piece will be there. Right? Who's going to do some validation? Second. Now, who is going to issue the certificate? Maybe the institution is going to issue the certificate. Now, how he is going to get it? Now, he has the raw data. We call them as a certificate data. Right? Or he's going to collect all the certificate data. And he's going to create the hash, generate the hash for the certificate data. Generate the hash for the data. And then we are going to use the chain code. We are going to use the chain code, which you're going to have. Right? Now call issue function. And then that this hash function, which you're going to store into the blockchain, only hash values will be stored. Right? And it is going to, that valid transaction will be stored into the block. And then the raw certificate, what we call them as what we are going to create a consolidated certificate. And then the consolidated certificate hash value will be stored in the blockchain. Will be stored in the blockchain. And then we are going to issue the final certificate, which will be digitally signed. A consolidated will be digitally signed along with the blockchain ID, and a digital certificate will be given to the stakeholder. To the stakeholder. Right? Now, what the verifier will do, right? Whenever the student has given the signed digital certificate, or a student want to see it, a signed digital certificate will be there. He will unsign it, means he will verify it, and he will get the data. He will extract that. He will get the data, extract the certificate data, and then send the data and hash for the verification. Once again, this data we are going to create the hash, calculated hash, and verify hash need to be there. If both are same, if both are same, then because the generated hash will be there in the blockchain, and calculated hash will be sent. If both are matching, it will publish. Yes, the verification, the certificate is valid and it is verified successfully. So this is a call verify function is going to work in such a way. So we are going to have, we have created a issuer role and the verifier role. The blockchain is going to sit in the middle as a distributed trust, and it is going to send the, it is going to communicate between the various stakeholders. I request the participants, please see this diagram, how it is going to happen. Now you see, now administrator is going to create a blockchain ID. This blockchain ID request, register request will send to the registered CA. Registered CA is going to generate the blockchain ID or enrollment ID or password, right? And then he's going to, this password need to be known to all the CAs. Therefore, TLS request for the TLS certificate, and generate the TLS certificate for the blockchain ID and the password, which will be signed by the TLS CA, step number 4. And then this TLS, store the TLS certificate and send back to the RCA. RCA will send that blockchain ID and password to the user ID. Then using the blockchain ID and the password, the client is going to send the enroll request to the enrollment CA. Enrollment CA will verify the credentials which has been received from RCert, and is going to generate the signed certificate, will be signed by the certificate authority of the enrollment, and is going to get the public key of that. This is a public key. The enrollment certificate will work like a public key. Then along with the public key, right, that will be stored in the client application, in the wallet, and then the client TLS certificate request, this can be verified. That's why this can be sent to the CA, which will, they have been generated. And then again, the TLS sign certificate will be done by the TLS, because this should be known by all the members of the peer. So this public key will be signed by the TLS certificate that will be sent to the client application. Okay, so this and then he is requesting T-cert. Next, the issuer is going to generate, because you want to issue this transaction. For that, what we need to do, client certificate will be sent to generate, and is going to generate T-cert. This T-cert will be generated by the TLSCA, and then the user is going to get the user is going to get to generate its own private key from the public key. He can generate the private key. That private key and public key relationship is going to be there. So this is a way where he is going to get the password, blockchain ID, public key, and the private key will be known once the registration process is completed. You're able to follow me?
Yes, sir. Yes, sir.
Thank you. Now, this is the way of how the issuing the certificate. Just now I explained in the previous, and this is the flow chart. Both are same only. And this is for verification. I have shown in the diagram, in the form of diagrammatically. This is the internal process of Hyperledger, which is going to be happening. Okay. And this is a storing of academic certificate. You see, this is a certificate. The hash of that certificate will be stored here. This is a certificate. This is a hash of the certificate. This is a certificate. This is a hash of that. These two hashes will be stored here. These two hashes will be stored here. These two hashes will be stored here. These two hashes will be stored. These two hashes, and what type of tree it is? What type of tree? Can anyone tell me? Because you have come across from last 3 to 4 days blockchain. What type of
tree?
It is a Merkle tree. Very good, man. It's a Merkle tree. It's a Merkle tree whose root is going to store in the block, right? It's a Merkle tree which you're going to use. It. Same concept we are going to apply. We have used in the blockchain for storing the academic certificates. Now, this is a way that how the use case. First, this is a step for generating the keys. We are going to use the run the code called generate.sh file. Once we generated the file, what we are going to get it here in the sense, generating the hash file, which you are going to use it here, we'll get the secret key. From where? From ca.org example.certificate.pem. We get the private and public key is going to be generated from that. Once we get the certificate, this certificate we can even see in the issuer's file. We can store that SK file here. Fabric CS server file will be stored here. That key credentials which you can store. Then once we get the stored, then we need to start the blockchain network. We need to start the blockchain network. Right? Once the blockchain network is initiated, then this blockchain network will start, and it will take time, maybe 15 to 20 minutes to initiate the network, to start the network. And then you see chain code is successfully invoked and blockchain is set up already. Network is started. It will take some time to start the network. Once the network is initiated and it is completed, then we can see who are the members of the blockchain. We can see OachDB, which is a shared database, orderer. We can have a CA, which is MSB. We have a command line interface. We have a peer 0, peer 1 can be created. All this information will be stored in the blockchain for one organization. So if you have multiple organizations like 1, 2, 3, 4, all the organization information we can store and we can view. If something goes wrong, immediately we can get the data. Now this is a gateway. This is a gateway which we have created from the app to the blockchain network internal view. So ID is there. This ID for each everything. MAC address will be there. IPv4 address will be there. IPv6 we have not used. Subnet and gateway, everything, a network is created. so that we can communicate very effectively with the blockchain network. Any app application which you are running, we can connect it to the blockchain network. These are the various members of the peers. All these things will be there in the internal network. Okay, so this is the internal view of the blockchain network we are going to add. Once it is over, then we are going to run. Your blockchain is up now, your network is up, then we can run the front end by running the Node.js server.js file, where it is running the port 700. Once it is running on the port, which we are going to get it here, you see, localhost 7002, my issuer, where you can enter the credentials of the student, roll number, unique ID, select the grade, and student faculty can enter the details immediately, and it will enter. It will create the hash value of that, and it will be validated, and it will be stored into the blockchain. Once we entered it, and then once we issue the certificate for that, by all these things, we can consolidate the certificate can be there, and then we are going to generate a certificate.json file will be there, which will be encrypted. We call them as what? Encrypted JSON format, EJF. Encrypted JSON format file will be there. That we are going to save that file, and then we are going to click the OK. JSON file will be created. Once it is created, then anyone can verify it using the hash value. Using the hash value comparison is there. If hash value is compared, then we can say the result is successfully executed, and its value is there. If we entered wrong value, whatever we are going to have it, the hash value will be different, and it is going to fail. This is failed, and this is pass. So this is a verification is going to fail. Means the certificate is not available in the blockchain. So this is the way that we have created so many use cases like electronic health records, Internet of autonomous vehicles, we did it, identity management, we did it on Hyperledger. There's so many applications we can do in the Hyperledger. That's it from my side. Thank you. And if you have any queries, please let me know.
Any questions from the participants? Ashok Kumar.
Sir.
Any question?
Hello.
Any question?
Sir, from my side, one small question, sir. Of course, it is not a doubt. Just I'm going to ask Suresh sir. Sir.
Yes, sir. Yes, sir.
Just now told Hyperledger Fabric is a confidential. You mentioned that word, sir. How we can say it is a confidential, sir? Of course, the cryptography itself it is a confidential, but you mentioned that word for especially for Hyperledger Fabric.
See, for a very good question, sir. Actually, a blockchain Hyperledger Fabric is a platform. Is a permission network platform. Now, what we need to have, first of all, we need to establish a network. Suppose, for example, I'll give as a case study. If this FDP is there, now in order to organize this FDP, actually, Swami sir need to start from 3 months before, right? 3 months before once we get the Now we need to establish a blockchain network first. Means blockchain network means you need to take the approval from the university. You need to get the approval from the AICT. You need to get all these things. You need to do it. Means even not only you need to take the permission from the head of the department. You need to ask head of the department to assign some faculty members to organize, to coordinate the people. All the members are nothing but peace, isn't it? Now, once the process is started, then you will send the call for participation for this FDP program. Then participants, what will do? They will get the approval. Now they will get the approval from their institution, and then the application will come to you. Assume that you are one of the peer now. Now, the application is a confidential one. No one knows that application except the person who has sent the transaction. That's a confidential transaction between the user and the assigned. Who actually you are the person which will be assigned by your HOD or someone, so that between you only the transaction will be visible. No other people can visible the transaction. In such cases, we can ensure the confidentiality will be there.
Okay, right, sir. Right, sir. Thank you, sir. Thank you.
Yes.
Any questions? Any questions from the participants? Sir, Malleshwara sir? Sir. Malleshwara sir, any question from your side, sir?
Yeah, actually, in an abstract way, I'm interested to know how an intruder using a quantum computer can attack blockchain security.
Yes, sir. Very good question, actually. See, whenever we go for quantum computer, I think Google is already started working on quantum computer. Whenever quantum computer comes, no security mechanism now, whatever it is there, it is, we can easily break the any crypto system. Current blockchain system makes use of existing cryptography like electrical cryptography or a lattice-based cryptography or RSA cryptography system it is using. Now, when we are finding the prime factors, or when we are using when we are going to use the keys, if you use quantum computer, it is very within seconds you are going to get those keys.
Okay, sir. Okay.
Now we need to apply. That's why quantum-based cryptography need to apply for the blockchain.
Yeah. Yeah.
Quantum-based cryptography need to apply for the blockchain. Definitely, it will be protected from quantum computers.
Yeah. Right. Thank you.
Yes.
Any questions from the participants? Any questions from the participants? Thank you, sir. Thank you for your wonderful lecture. And sir discussed problems with centralized systems, technological advances, and centralized to decentralized, and types of blockchain and blockchain classification and simplified fabric architecture. And all these are useful for our young researchers, sir. Thank you, sir. For your area is great benefit for our participants and our researchers, sir. Thank you, sir. Thank you once again. Thank you very much for your wonderful lecture, sir.
I thank each and every participant, especially the coordinator, all the learned professors, for pairing me these 2 hours to result my class, which is very difficult sitting online and listening the classes. And they bade me, whenever I'm asking a question, they're taking time to send the message. That's a good sign. They're more active. I thank each and every participant for in this regard. And I thank especially the coordinator, Swami sir, who invited me to give a lecture on the blockchain technology. I thank you, sir. Thank you, one and all.
Thank you, sir. Thank you, sir. Suresh Babu, sir. Thank you for accepting our invitation and delivering the lecture on this AICTE ATAL FDP 5-day FDP program on the impact of quantum computing and on cryptography and blockchain technology. Sir. Thank you very much for your cooperation. Sir. Thank you. Yes, sir. Okay.
May I quit, sir, now?
Yes, sir. Yes, sir.
Thank you, one and all.
Thank you. Thank you very much. Okay, participants, I kept session 12 link in chat box, as well as session 10, 11 also I kept in morning session, and in second session regarding the feedback link, I received some comments from 4 to 5 participants. Anyhow, I received more than 70 responses for that at that time. Now it is almost around 100. So I think there is no problem with session 10 session 11 exactly. So, however, once again I shared session 10, session 11 as well as current session 12 links in chat box. So I'm requesting each and every participant should fill this. We will treat as your attendance as well as we will download your attendance from Zoom, which are we will submit to AICTE after completion of the FDP. Then only AICTE will give attendance participation certificate to you. At the end of, tomorrow is the last day for our journey. So I'm requesting each and every participant should join the FDP on time. And tomorrow, very important thing is that our session will start at the sharply at 9:15 because this is very useful for each and every participant because our AICTE instructed each coordinator to conduct FDP in 14 sessions. Particularly, AICTE mentioned one thing about one session particularly, that is a compulsory session. Coordinator will be free to invite experts for one compulsory session. That one is nothing but out of 14 total sessions, which is on the mental and emotional development, stress management, meditation, human values and ethics, health and happiness, etc. or IKS, Indian Knowledge System, which may be conducted by any spiritual, social organizations or individuals like Art of Living or similar organization to promote Fit India movement. Note that FIT, Fit India movement of a central government, which is a central government program. So under this Fit India movement, and of course our IKS, that is the Indian Knowledge System, about glory of ancient Indian achievements in various fields across the country. So either we can conduct a program, we should conduct one session on Fit India movement or else IKS, that is nothing but Indian Knowledge System or Fit India movement system. So under Fit India, I have requested one speaker, is Mr. B.K. Balakishore. You can search B.K. Balakishore through Google. So he is the international speaker and Vice President Transformation of CS Software. And his title is Science of Meditation. Right. Of course, in our BCom so far we have conducted almost 4 AICTE FDPs in recent years. Particularly, almost all remaining FDP coordinators tried to take to have this speaker, Mr. B.K. Balakishore. He is the international speaker, but we are lucky. He gave us time. And he is going to deliver his lecture tomorrow at morning 9:15. However, so 9:15 to 11:15, I am requesting everyone should be attentive about this lecture. Definitely, this will help you in building your health, particularly because AICTE also instructed one session on this under FIT, Fit India movement. So under Fit India movement, this session will help you a lot. So I'm expecting every participant should join for this program by 9:15. So we'll start our session at 9:15. Just after the introduction, he may start his lecture at 9:20. So don't miss tomorrow's sessions. One is 9:15 to 11:15, which is the session specially dedicated under Fit India movement. Under this, he is the person Balakishore going to do his talk on science of meditation. You can observe title itself indicates as something new and definitely it will help you in taking care about our health, right? And after that, we have section 14, and which is going to be given by Dr. D. Ramesh, Indian Institute of Technology. Earlier, it is known as ISM, Dhanbad. And the title of Dr. D. Ramesh is Formalizing Cloud Storage with Blockchain. So we are very close to conclude the 5-day FDP. So only one more day to spend. So I'm requesting each and every participant to join for the 2 sessions. After that, in afternoon at 2:15, we will conduct one exam. Everyone should pass that exam. Right? Attendance is 80%, which is important, as well as in exam also everyone should get 60% marks. That was the instruction I received from AICTE. So that is why I'm requesting each and every participant to write exam which is going to conduct tomorrow at 2:15. So I'm planning for 20 questions, right? So in that, out of 20 questions, everyone should get 60% marks in the test. Here, I'm going to read these instructions, candidates. Test and the certificate. Under this, we are given ABCD. 4 rules are given to us. One is a test shall be conducted, maybe online, by coordinator at the end of the program. Right? Next one is the question bank with answers key must be shared on portal in PDF or Word format by the coordinator, which I have to upload for AICTE after completion of the exam. The certificates shall be issued to those participants who are registered on ATAL portal and attend the program with a minimum 80%, 80% attendance and score minimum 60% marks in the test. And the last condition is feedback must be shared by the participants through portal available on their login. So even if we have 80% attendance as well as 60% marks, feedback is also very important. That feed, of course, tomorrow also we have feedback in mandatory session. Don't confuse with this feedback and the feedback which is given by AICTE. Right? AICTE asking feedback. Each individual they have to submit their feedback in their AICTE portal. That is very important. For each individual, if you go to AICTE portal, there is you have to log in to AICTE ATAL portal. There, when you open your page, you can observe feedback. Maybe last but one heading is there, which you have to fill after completion of this program, right? So after completion of this program, you to fill that feedback which is available in your AICTE ATAL portal. That is very important. So please go through the feedback which is given in AICTE ATAL portal. That one you have to fill after completion of the program, participants. Don't do it early. After 4:15 only. Tomorrow after 4:15 you have to do that. For them only they will issue the certificates on the basis of the coordinator. I mean, I have to submit attendance list as well as percentage of marks list of each candidate. I mean, how many candidates are registered and how many candidates reached 80% attendance as well as 60% marks in test. That list I will give. I will upload to AICTE. Then AICTE will issue a certificate to you. So I'm requesting each and every participant should attend the tomorrow exam 2:15. From 2:15 to 3, we are going to conduct one exam. At 3 o'clock, validation will start. In that, we'll take a few feedbacks from participants. And by 4:15, we will conclude our session tomorrow. After completion of validation, you have to submit your feedbacks to your AICT. You have to once again you have to log into your AICT portal. There you can find your feedback, which you have to fill and submit. Meanwhile, I will also upload the data of the participants who made the condition, particularly minimum 80% attendance and minimum 60% marks in the test. That data also I will upload. So I am requesting each and every participant, don't miss tomorrow two sessions, as well as particularly last session. I am going to conduct exam at 2:15 particularly, and it will end by 3. So at 3 o'clock, valedictory session will start. Don't miss. Is there any doubt? If you have any doubt, you can unmute and speak. If there is no doubt, you can leave the session. Participants, respected professors and their colleagues and dear research students, if you have any doubts, you can unmute and you can ask me.
Sir, please send feedback form again.
Feedback form of this session, sir? Okay,
Yes, sir. Yes.
Okay, okay. Lalit Neji, any problem regarding session 10 feedback form? It was completed by you. What about
No.
session 10?
Sir, feedback link open. Please send the feedback link, sir.
Okay, sir. Ashish, sir. Is the exam is in SS 65 IDC? Yes, exam is going to conduct in MCQ form. Yes, we are planning 20 questions. Each question carries 3 marks. I mean, that is what we are thinking. I mean, once again, I have to go through AICT pattern. Maybe 3 or 5 marks that will check. So maybe 5 marks, of course. Okay. Please send feedback. Exam is in MCQ pattern in which you should get 60%. Section 12 feedback link is provided in the chart box. The participants, those who are completed, they can leave the session within 1 or 2 minutes. I am going to end up the session. I am going to end the Quran. Participants who are completed, they can leave the session. I am requesting remaining participants to fill session 12 feedback within a minute. Okay. Okay. Thank you, Ashok. And thank you, participants. Can I wind up? Can I end the meeting for now?
Sir, excuse me.
Yes, Madhulata, madam.
Sir, tomorrow are we going to have a bit paper or descriptive type exam?
MCQ type question, sir. Multiple choice. MCQ.
Okay, right, sir. Thank you.
Okay, thank you.
This exam will be difficult.
Sir, Chandulal, sir.
The exam చాలా హార్డ్ గా ఉంటుందా సార్?
According to AICT norms, you should get 60%, sir.
Sir. Okay, sir.
Okay, thank you, sir. Thank you. I hope everyone may pass, don't worry. Almost majority of people attended regularly. Those who are attended regularly, they can easily get 60%, not 60, you may get 90% also. Don't worry about that. Okay, sir?
Okay, sir. Okay, sir.
You are regularly, attended regularly, that is very, you are attended regularly, for them it is not a problem. Okay, sir.
Thank you, sir.
Thank you, sir. Thank you, participants. I am going to end meeting.